Hi there, we're looking at the surface area of a cone in this lesson. Before we proceed, we'll do a prep quiz, and you can pause and you can complete this section from 1 to 10 and then check your answers. So let me solve these ones. This circle with the radius s has an area of pi r square, r being s here, pi s square. Circumference of the same circle is 2 pi r, which is 2 pi s. If you have to simplify this expression, 2 pi divided by 2 pi will be 1, so I will get r over L. Simplifying this expression, we'll have L square divided by L will get me L in the numerator, so this is pi r L. Number 5, what fraction of a circle is each of the following sectors? Here I have 90 degrees out of 360, which is a quarter of pi. If the circle has still the radius of s, pi s square. In this case, I have 120 degrees, so 120 degrees out of 360 into pi s square again, presuming that's the same circle with the s radius. Number 7, they are telling us that the circumference of the whole circle is 9, whereas the sector has the arc length of 3 centimeters. So since I don't have an angle, I can extrapolate the idea of the fractional sector as 3 centimeters of the circumference out of the full circumference of the circle, which is 9. So 3 out of 9 is what I'm looking at. So basically I'm saying 3 centimeters, this one, of the whole circle, which is 9. So that will be 3 over 9 times pi s square. Or presuming that is still the radius s, or if I don't know the radius, then I'll have to simply use this s here. All right, number 8, I have 6 centimeters out of, I don't know the full circumference, so I will simply say 2 pi s, and the area of that whole circle is pi s square. Does that make sense? The whole circumference, it was given here as 9. In this case, I have got 2 pi s, s being the radius. I'm getting the radius from here. In this case, I'm being told the circumference is 2 pi l. That implies that this is the radius L. And they're telling me that the path circumference, or the length of the arc of that sector, is 2 pi r. So I'm using 2 pi r out of 2 pi l of the whole circle, and the whole circle radius is L, so pi L square. Okay, so that's for number 9. Now number 10, evaluate pi r L if r is equal to 3.5 and L is 6.5. Correct to 1 decimal place. Of course, you can use the calculator. Check this one. Right, let's move further. I want you to do a hands-on exercise. I want you to take a suitable radius that fits on an A4 size paper, not too small, big enough so that you can work with it easily. So probably if you take half the width of the paper, so you can draw a circle, cut out a circle, and with that suitable radius, probably 10 centimeters, I want you to cut out this shape. And it doesn't have to be exactly 90 degrees. It can be about 75, 80, even 100, 110 degrees. It doesn't matter. A certain angle has been cut off. Now, once you do that, what I want you to do is fold it and work backwards and draw a cone. So once you've aligned these edges, AB with AB here, you will end up getting that joint, and then you will end up putting a small tape here, and you will see that this is a cone, and you have to simply put a circle at the bottom. Now you'll note that this circle, the base of that cone, is not the same radius as this one. Here, this is going to be a different radius. Now here we have mentioned this to be L. And the reason why they've said this L, because this edge or this AB becomes the slant height of the cone once you join these things together. So there's a reason why they have called this one L, because that's a slant height. Whereas the base has a radius of R. So once we say a cone with a radius R, so we're talking about this radius of the cone, which is small r, which is this one. I hope this makes sense. So we need to understand that the L, which happens to be the radius of the sector, which forms the curved surface, this curved surface of the cone. Okay, now what we're going to do is we're going to identify the surface area of this curved surface. How do you find the surface area of this curved surface? You'll see that I have 2 pi r as the length of the arc of that sector, and that as a fraction of the complete circumference, which would be 2 pi l, because this is the radius of this circle. So 2 pi l. Now what is the area of this complete circle with L being the radius is pi r square, which is pi L square. If you simplify this, you'll have 2 pi divided by 2 pi and L square divided by L, so you'll get pi RL. So the curved surface area is pi RL. And what is the area of the base of the cone? If the radius is r for that circle, pi r square. So the total area of the cone will be achieved if you add these two together, pi RL plus pi r square. Okay, so the total surface area is pi RL plus pi r square of the cone. Now, if you don't know the curved length, or this L, you don't know this curved length, then you can use the height of the cone given to you, that the height of the cone, which is normally given if in case they want you to calculate the slant length, and the base radius or the radius of the cone is given. So you can calculate this using the Pythagoras theorem, which is equal to root of h square plus r square. Okay, so the surface area of the cone, this is the formula, is pi RL plus pi r square. And if you don't have the L, you can use this sketch h and r to find the slant length L. Okay, let's look at the worked example. There are two examples here. A slant height L is 8 centimeters, and we expected to find the surface area of a cone with a radius of 5. So r is equal to 5 centimeters. The surface area of the cone will be surface area is equal to pi RL plus pi r square. Now pi and r is 5 into L is 8 plus pi, radius is 5 square. You will get this thing in centimeters square. Use your calculator please and find this answer. All right, second one, the height of 12. So if I have height of 12 and the radius is given to me as 5, I need to find the slant height, which is L, which will be root of 12 square plus 5 square, correct? So that's 144 plus 25, that's 169, that's 13 centimeters. So now the surface area of this cone with a height of 12, so this cone obviously has a height of 12 and the radius of 5. We did not know the length L. So the surface area of this is pi RL plus pi r square. pi r l, pi into 5 into l is 13 plus pi, and the radius of the cone is 5 square, pi 5 square. Please use a calculator. Your answer should be in centimeter squares. All right, you can continue with the exercise. And while we are at this, I would also want to see if in case we can do the next one, which is surface area of a sphere. For the surface area of the sphere, there is no derivation in year 10. So we simply need to know the formula, and the formula is 4 times pi r square. So the surface area of the sphere is given by this formula, 4 pi r square. And r is the radius of the sphere. Okay. So let's do a couple of examples here. I will quickly go through, rather than putting the detailed calculations, I'll quickly go through the quick calculation. Surface area for this figure, we see that this one has a hemisphere on the top. That means hemisphere is half of the sphere, and the cone. Now, if in case we are finding the surface area of a solid here, we will obviously not account for that base of the cone, right? Neither the base of the hemisphere. We will only take the outside surface and the outside curved surface of the cone. So we notice that there's a cone here, and we have a hemisphere, rather half of the sphere. So the surface area of the sphere will be half 4 pi r square. That's the formula, 4 pi r square from here. And this is half times 4 pi r square, because this is a hemisphere, that's why we did half, plus the curved surface area. If this is the slant height, and that will be given by 10 square plus 5 square. So if I know the length, then my curved surface area is pi r l, and I'm not adding the base because that is not the surface area of the solid, that is inside the surface, inside the solid. So if you plug in these values, and L can be found using this formula. The second one, here I have a hemisphere on the top, a cylinder, only the curved surface, and then I have a hemisphere here, but on the side I have an annular ring. This section is called the annulus. Now this section, what we can do is find the radius, this radius, and I can find this radius, subtract the two circles, I'll get the annular ring. And the big radius is 8, so this is 8, and the smaller radius is of course 4. So I can say pi 8 square minus pi 4 square will become the annulus. So annulus area is equal to the bigger circle with the diameter of 16 is pi 8 square minus smaller circle, which happens to be with the radius of 4, that's pi 4 square. That's the annulus area. And the area of the hemisphere, because it's half of the sphere, is the radius is 8, half of 4 pi 8 square. So annulus area is this one, pi 8 square minus pi 4 square, plus I've added the annulus area, I've added the sphere. Let's move on to the curved surface. The curved surface, once open, of the cylinder will be pi 4 square, this is 4, pi 4 square into height of 8. So this is 2 pi 4. So 2 pi into 4 into 8. That will give me the curved surface area, plus the small hemisphere on the top with the radius of 4. So that is 4 pi 4 square divided by 2. And that should be the answer in centimeter square. Let's look at this one. The surface area of this one. This one is a hemisphere, so I can use this one. Now over here, I need to find the surface area of this whole cone and subtract the surface area of this cone, which is drawn in the dotted line here. So I need to find AC and I need to know AD, correct? So I know AC from knowing BC. BC is 0.6 and AB is 0.8. I can find small l and then I can find the capital L from A to the whole end. Capital L I can find using AO. AO is 4 and OD is 3. So I can find capital L using Pythagoras theorem. So what I can do is pi RL minus pi r small l. That should give me the curved surface area of this truncated cone. Okay, the one that has been cut off, so it's part of a cone. And then I can add the surface area of this sphere, which is half of 4 pi r square, and the radius is OD, and OD is coming from here. Okay, I hope you can get this. This was one of the red questions, and if you have any difficulty, please post your questions on Teams and we can address them. Thank you so much.